This is week before AP Chem test, and we want to be ready. And if you guys don't do the work, can't really help you here, right? I guess like listening to my review would because I do end up going over all the questions. But I still would like to see you try on your own and then see how that goes. That's why I sometimes include um, interactive sessions where I ask you what you guys put down and give you, individual feedback. So hopefully, that's only an extension of how interactive this gets. But I think on your end, you have to provide your work so I can see it. I don't look at all the details, but I do every single class after class. I do look at those and I do give you feedback if I see that something's really off. And so look out for my comments, and I also put in all the grades for our okay, Catherine, that's fine. And I also give you guys feedback on your homework assignments, like the intermolecular test that only 2 people did, and thermochem, like 3 people did. If you did it, you already have my feedback, my handwritten notes. If you needed help with the calculation part of the question, then I wrote everything down and put it on your Google Sheet. So make sure you guys check that feedback, and then ask me questions if you still don't know what to do with that with those questions. All right. So without further ado, number one is our first. Number one, part A is going to be the first one. Again, we know that because we just did equilibrium chapter, we know that one of the most common ways of starting an equilibrium question is by asking you, hey, let's find out the equilibrium constant expression. And we know that for this one, we just have to look at the individual ions and how many there are in terms of like the coefficient according to the equation that we're given. So we know that we have, let's highlight, we are given 2 moles of silver ion and 1 mole of chromate ion, and so we're going to report it as KSP is equal to concentration of silver to the second power times concentration of chromate ion, and that's not gonna have any power because we know it's just 1 in front of it, so easy stuff. And 1B is asking us scoring, right? Oh, my bad. Almost forgot it. So for this question, I hope you all have access to the results, um, the test result Google sheet, and this was just 1 point for getting it right. Number two, part B of number one, we do get 2 points. Let's see how that breaks down. So for this, we could have done ice table, or we could have just done the stoichiometry that's related to this. So we know that we're going to have, if you have X amount of chromate ion, then silver ion wise, it's going to be just 2x. So we know that KSP wise is going to be 2x to the second power times x. And our KSP value is given over here, and that is 2.6 times 10 to the negative 12th power. And so 2x squared times x is going to equal to that. Solve for x, you get 8.7 times 10 to the negative 5th power. And that is chromate's concentration, but we're really looking for, in this case, it's going to be silver concentration, so we know that we have to double that to get our final answer. 1.7 times 10 to the negative 4th is going to be our answer. And we are going to get 2 points. First one for the work, the stoichiometry that you went through, considering the fact that once you find x, we have to double that. And of course, 1 point for correctly calculating silver ion concentration. So we know that we get 2 points for the following. So this is going to get you 1 point. And of course, the answer itself is going to get you another point. All right, so I just got a notification saying one of us handed in our work. Thank you, Sean. Just got it. All right, so now let's move on to part C. Part C, we have calculate the maximum mass in grams of silver chromate that can dissolve in 100 milliliters of water at 25 degrees Celsius. So for this one, we have to do some serious dimensional analysis. Sean asked, is it okay if I submit it as a PDF? Yes, that's okay. I can look at every type of file. All right, so for this one, I think I overdid my work because you can kind of assume certain things here, but I just wanted you to have a full-blown work here. So we are going to start with 8.7 times 10 to the negative 5th moles of chromate over liter, and that's something that we found from 1B. That was our value for x. So with that concentration of chromate ion, we're going to now use some molar ratio here. So for every mole of chromate ion, we're going to have 1 mole of silver chromate. So I have that as my second fraction that I'm multiplying this by. And then, of course, I want to have grams of silver chromate in the end, so I'm going to use my molar mass of silver chromate. Of course, using the periodic table here. And we're not done. We were asked, so how much can we dissolve in 100 milliliters? So we're going to multiply that by 100 milliliter. And because we can't just multiply that, since we have to cross out the liters in the end, we're going to change 100 milliliters to 0.1 liter, or just multiply by 1 over 1000. And as you can see, all the units will cancel out, and we are going to end up with grams of silver chromate, and our final value is going to be 0.0029 grams of silver chromate. And for this one, we have 2 points. Of course, one for the middle work here. We had to find the molar mass of silver chromate to get this right. So, of course, you would have it somewhere, but if you did this work and it's implicit, or at least you state it somewhere in your work, then you're going to get that point. And then, of course, the final answer, if you find the mass of silver chromate in 100 milliliters, then you're going to get another point. So we are going to say this is a point, and that's another. Okay,